Let's get started. Last session of the day. Thanks everyone for, hanging in there until the very end. Although I suspect that maybe the free beer they offered might have something to do with that. This session is going to be about two questions really. Number one is how do you best go about integrating legacy software? That's something that's been, coming up every now and again to me over the last few years. And obviously, the one in reference in the title is what really gave the inspiration for this one. And the second one is based on that and looking at past legacy integrations, what can we learn on how to come up with, future-proof software architecture, future-proof software systems. And before we get into it, I have to do the traditional, the speaker introduces themselves slide. I'd like to keep this one short though, because it's admittedly, it's a bit awkward this time. So I work for Deutsche Bahn and I suspect maybe a few of you are impacted by the strike as well. I am too. We're all in the same thing together here. I came in by train last night. I intended to leave maybe tomorrow morning. I won't. But, the way I see it, really, there's worse places you can end up stranded than Zurich, right? So let's try and make the best of it. Okay, so let's get to it. I'm usually not a big fan of these kind of, history lesson slides, but since we're talking about a time frame of 40 years, I think I'd be willing to make an exception. So this all started in, basically 1980 when the executive board of Deutsche Bahn decided that they wanted to take our booking system into the, well, I guess you could say, digital age. And they devised a plan of having the entire booking process as a digital process by 1990. And one of the first systems they built to realize that plan is the one that gave the title. It's called EPA. It's short for Elektronische Platzbuchungsanlage. It's such a beautifully German word. It brings a tear to my eye every time. I'm sure the native speakers can appreciate it. And it went into production in 1983. And if we skip ahead to the very end of the timeline, you can see, I believe the current plan is to finally lay it to rest in 2026 or maybe 2025, I'm not quite sure. And then by then it'll be, 43 years old actually. And to keep things as short as possible, by the time in 2001, so that's like when the original sales system had been like 10 years old, the new executive board assessed that, it was deemed aged and with grave technical risks, and that includes EPA. And there have been two entire renewals of the sales system after that. The most recent one I've been involved with. And by the way, 1991, when the original one was finished, that's the year I was born. And in 2023, in I think fall last year, we actually took the most recent one into production. And so what we had to do was, when we started out in 2017, 2018, was that our idea was for the new sales system, we wanted to go into production as early as possible to get, early feedback, the way people suggest you should. Does my hair look good, Dimitris? Now, our idea was that we wanted to go into production as early as possible. Like, ultimately, our goal was to, replace EPA with so what it does is it basically translates to it's a seat reservation system, right? And ultimately our goal was to replace it with a new seat reservation system, but we couldn't do that because we quickly realized it would be a difficult one to replace. And so we started out by integrating the main features we needed, because to sell tickets, we would need to be able to, sell seats as well to our customers. And ultimately, interestingly, what was the downfall or the last nail in the coffin for EPA is going to be is, it being 40 years old is, remarkable in and by itself, but it would probably be able to keep on running after that. Like, it's not that it's failing, it's not that it doesn't work anymore. Obviously, it's being hard to maintain, but actually what's going to kill it is that the runtime is no longer being supported. So it was written in COBOL and it runs on an HP non-stop host system. And the point has come where, even HP, I mean, you can imagine the desperation that the sales department of HP would say, no matter how much money you bring, we can't seriously keep supporting this any longer. And they basically set a deadline. And so, finally, there's no way around it anymore. And we're going to have to replace it. But first, we needed to integrate some of the core functionality. And that's what we're going to look at with regards to the first question, how do you go about integrating legacy software? Right, and the first step, this is going to be painful for my fellow nerds here, but in my opinion, what you really got to do is you got to talk to people. Like you need to talk to the people who build it, who maintain it, and who run it. And in this case, it actually turned out like obviously there's like an operations team. But at this point, after 40 years, people who were originally involved with this, they were mostly retired and some of them even deceased. It's not exaggerated. So this was actually a bit tricky. And so the next thing you do is obviously you look at the documentation. And at this point, I was prepared that they would tell me to, go down to the library and look at the written paper. But we were delighted to find that at some point they decided to move the documentation into a digital format as well. And they went for plain HTML and CSS. And we were like, great, it's amazing. They came up with the documentation that's probably like 20 years old and you can still access it today. I mean, that's great. Nowadays most people use, for example, I don't know, Confluence. Is Confluence going to be, around still in 20, 40 years? I have no idea, but I have my doubts. Anyway, our joy was short-lived because unfortunately they decided that they wanted to make the documentation fancy and to have a fancy menu and a fancy layout. They did ActiveX, and if you use any modern day browser, they just flat out refuse to open it and say, it's a huge security risk, you can't do it. And so there's actually documentation on how to make the documentation accessible, but still, it's a huge pain. And then the last resort, and that one's actually come up with all the legacy I've been working on, you have to find the one guy who's sort of the mastermind behind everything. And I'm actually quite proud of this one, because if you knew the guy, like the actual guy, it's a very accurate picture, like even down to, hairstyle, beard, clothing, everything. That's basically him. And so he's the kind of guy who joined Deutsche Bahn like 40 years ago, and he was there when they initially started working on IPA. And he's been around for 40 years with the same company. And he's the guy you need to ask to explain everything, because pretty much everybody else treated this system, IPA, as sort of a black box. It mostly did what you would expect it to do, but he could oftentimes explain why and how it does things. And so, we started essentially spending a few days just picking his brain. And I believe the first thing he said to us, I can remember quite clearly actually, was that he said something along the lines of, "So you're the new guys." And we were like, "What do you mean?" And he said, "Well, there's been at least 2 serious attempts at replacing the system, and they both failed phenomenally." And we were like, how hard can it be? And we were about to find out. So obviously, when you think about how do we go about integrating it, you need to look at what are the core features that this system offers. And so we asked him, explain to us what IPA can do and what part of that is still relevant to a modern day sales system where you're selling tickets on trains. And he said, well, the first one is not going to be very surprising. You can do seat reservations on trains. Okay, that's truly not surprising. That involves, making reservations, blocking seats. You can cancel reservations and free them up again. And there's some special things. For example, we have something called graphical seat display. Those of you who've booked tickets on an airline, it's like you get a graphical representation of what the train looks like, and you can decide, what seat exactly you want to sit on, and so on and so forth. Okay, then he said, also, there are some journeys where our customers travel not only by train, but also by bus or even by ferry. And with IPA, you can even make reservations on those. And that's a bit of a stretch, but if you accept that they might have numbered seats, like they probably don't have coaches the way trains do, they're still numbered seats, you can make reservations on them. Actually, fun fact, there's a route from Emden, a town in northern Germany, to the Isle of Borkum, where you go by ferry, and it's mandatory to have a seat reservation. And so, we need to have that as well. And then he went on and said, and you can also make reservations on car parks. And that's where, things start to get a little strange, I guess. And then finally, and this one's going to be fun, he said, oh, it can also do everything related to pricing, vouchers, and billing. Yeah, and that's interesting. Some of you made pretty much the same expression I made when I first heard that. The more experienced people are going to go, oh no, that's actually a bad thing. And why is that? Because, anyone who's ever worked on anything remotely e-commerce knows that everything related to, pricing, billing, and such should really be part of a separate domain, a separate system. And I guess the only real explanation for this is that, over 40 years, people have been kept on piling on features, and that's really, I don't know, it's the grandmother of feature creep, right? Yeah, and that's obviously going to be trouble because if you use EPA interfaces and tell it, make a reservation for me, then it's going to be okay, please pay me. When in reality, for our new sales system, we obviously have our separate domains for handling payment and stuff. So yeah, that's going to be a pain. Now, when it comes to doing integration of software systems, from an architecture point of view, especially, let's say, enterprise architecture is quite simple, right? We have two systems. So we have our new sales platform. It's called MOVAS. It's short for Mobility and Vending Services Platform, I believe. And then we have the reservation system EPA. Right, and for enterprise architecture, if you want to integrate both, it's quite easy. What you have to do is you draw a line and you're done. Now, we all know that's a bit of an oversimplification, and so one of the very best decisions we ever made in the entire project was that when you have in mind that we're doing this as sort of a temporary thing, remember our ultimate goal was to replace it. And so it might be a good idea to use a very simple but very powerful pattern called adapter, right? You put all the stuff you need for the EPA specifics into a separate component, the adapter. And then this way, when you want to finally replace EPA with a new seat reservation system, you just make movers point to the new adapter and in turn the new reservation system. And then, from the perspective of our new sales system, all the APIs, all the interface, everything is going to be stable, and you just have to replace the connection to the new adapter, and then you'll be fine. And I know it's a very simple pattern, but I can tell you this was one of the best decisions we ever made, really. It's just that with something so big, you need to be very, very careful to contain all the, specific stuff of, in this case, EPA, and really contain it in your adapter. Because over time, the longer you go on, the more features you integrate. It's going to be very hard because this stuff has a tendency of, creeping beyond the adapter into the system you're trying to protect. So you have to be very much on the lookout and try very hard to avoid that. And over the years, it's very tough to actually keep up to that. Now, aside from this obviously being a very simplified view, there's also something else you need to consider, and that's that in this case, there's actually two worlds that collide in terms of, technology. I mean, on the one hand, we have our 40-year-old system written in COBOL that runs on an HP non-stop host system. And then on the other hand, we have our new shiny sales platform, which comprises of, I don't know, 100 plus microservices in the cloud, deployed through a CI/CD pipeline. We can do all kinds of fancy stuff. We can scale up, scale down. It's developed in a test-driven manner and such. And so obviously the technological capabilities are quite different, and therefore you would be well advised to take a look at, in particular, the non-functional requirements. And that's what you should do next if you do integration, legacy integration like that. And the first one that comes to mind is, let's take a look at something such as peak load. Like how much load can you handle, how many requests per second, because we're web-based. And so, we sat down with Clemens and the guys, and we asked them, what does it look like? How much peak load can you handle? And what they said was, well, we can't really give you exact numbers, but we can tell you that if we are in fact overloaded, we don't really handle that too well. Okay, right? And then the next one is, what about response times? Like, what are we talking about here? And they said, oh, that's a great one. Usually, we're going to respond within 0.5 seconds, and that's actually, I think, respectable value, considering that, if you knew the details, there's some heavy lifting involved in some cases. And so I think 0.5 seconds is actually decent. And then they continued and said, but situationally, it can be up to 32 seconds. And I mean, at this point, how do you, for example, what would you consider to be a good timeout to do for this? Like, should you be doing 1 second, 5, 10, 15? No user is really going to be uh, continuously willing to wait 32 seconds. So that's really weird, but that's a good explanation for it, actually. What's going on in the background is that you can make reservations through our systems and book tickets, not only for German trains. For example, consider this. You make a booking from, say, Freiburg to Mannheim. That's two German cities. And for the entire journey, you're only going through Germany. Like there's no borders you cross. So why would this, for example, go to a reservation system from a different country? Because there are trains that serve this journey and they started here in Zurich. And so now you would assume, okay, then probably it's going to the SBB system, but actually it's going to ÖBB, the Austrian, because it's a night jet train, right? And you don't know that because you made a booking on this. You have your start point, your end point is German cities. You don't cross any borders, but still, for IPA to make the reservation, it needs to invoke the reservation system of the foreign country. And that's where things get tricky because some of our neighboring countries are known to be slow, and that's where, the delay in response time comes from. We're working on that. I'll get to that. But still, at least that's an explanation. And then the third one, when you look at like typical ones for non-functional requirements, authentication and security, I was prepared for the worst here, but then they said, okay, we can't do OAuth 2. Well, that's not surprising because that's, comparatively modern technology, but we can do TLS-SSL. And maybe like me, you would be a bit surprised and say, obviously you can do SSL. This has been around for as long as the internet has. I looked it up. Actually, what you would consider general availability of SSL has only been around since 2000. Whereas IPA has been in production since 1983. So to them, it had been a conscious effort to actually introduce SSL. So yeah, I guess we were happy to have that at least. Now, about request load and overload. As they mentioned earlier, they don't handle overload too well. And as a matter of fact, they don't really have any mechanisms in place to, shield themselves from systems who are authorized to communicate with it. And basically, it was up to us to prevent overloading them. And so, the first thing we had to do before we were even considering, doing an integration in production was to put in place some sort of mechanism that no matter what our users did, because, if if you're in the cloud and you can auto scale, potentially our platform could probably output something like 5,000 requests per second or even more, I don't know. And so we needed to put something into place to protect IPA from being overloaded. And so we came up with, like usually in today's time, you would probably have something like a service mesh to handle that, but obviously, like I'm not aware of any service mesh that would support HP nonstop. If any of you do, please let me know. And so we used Nginx for that to do the load limitation. And the way it looks is like this. So we have our adapter, which handles, the translation from, let's say, whatever it is our sales platform speaks to IPA, and then we put in between the Nginx as a load limitation device. And whenever, it detects that there's too many requests per second coming in, it'll just deny those and say, HTTP 429, too many requests, and then that's it. Now, the only challenge is how do you get to have, how do you choose your limits, right? They couldn't tell us specifically, and so we had no other option but to actually test it by doing load testing and stress testing. And unfortunately, because the runtime has become so, rare, the only system they have in place for doing production like testing is production, right? They only have this very one. Like there's another instance, but it can't be in any way compared to production. Like it's way less powerful and anything. So the only thing we had left was to test in production. And to find the limits, you need to sometimes exceed the limits. And so, sometime like in the middle of the night when people are unlikely to be doing, bookings and reservations, we actually killed it a few times to find some good limits. Yeah. So that's still a problem to this day. Actually, last day we had a situation where, something unexpected came up and still it was overloaded, and then we have to take countermeasures. Right. And the way it looks is like this. So when you get to the point where it gets overloaded, it's not like it'll just, continuously keep, failing bit by bit, but rather it's like a vertical bar. Like it goes from I answer all your requests to I refuse to answer any at all. And so that's why we have to be kind of, defensive with the limits we chose because it's better, in our case, it's better to be safe and, refuse a few too many requests than to let a few too many through and then overstress it because it will take a time for it to recover, actually. Now, another thing regarding peak load handling is what we always consider to be our worst case scenario when it comes to load, is that two things coincide. This has actually happened in the past, that there's, a strong storm that, causes, I don't know, trees fall down on the tracks and stuff, and at the same time you have people on strike. And what that results in is you have like 10,000s of people stranded at the train stations, and they're all, frantically typing on their phones and want to know if any of their train is going to run or not. And this is known to cause, well, in certain situations, over and more than 2,000 requests per second, and even more than that. Now, even for a modern system, 2,000 requests per second is quite a lot. I'm sure that if I approached any of you and asked you how would you design a system that handles 2,000 requests per second, you would take a minute to breathe, and your likely response would be the same as us. The only way realistically you could handle it is you need to introduce some sort of caching mechanism, because if you don't have that, if you only have the load limitation device and you have it to something like, let's say, for example, 50 requests per second, and you're getting 2,000 requests per second, then something like 90% of your users are just going to be shut out with HTTP 429. And so what we had to do was to introduce an additional component that caches all those requests. Right. One more note on, and so I guess, this works, but now all of a sudden, it's known, there's a famous quote, there's only two hard things in computer science. One is naming things, and the second is how do you do cache invalidation. And so now we have to solve cache invalidation as well. Great. An interesting side note, the way we did it with Nginx, I don't know if you've experienced with this tool or not. It's actually something we learned the hard way. If you Google something called the top 10 configuration mistakes to avoid in Nginx, it's number 3. It's that by default, it does not use persistent or keep alive connections. And as a fun fact, if you ever, I don't know if you knew that, I didn't. So the way the TLS protocol works is every time you establish a connection, there's a handshake phase where I think 3 packages are sent. And this one is compared to, handling actual requests that go through the connection. This one actually generates a certain amount of, computational power it takes to do the initial handshake phase. And in the times we did the stress tests, the EPA guys always told us, that the handshakes are what's killing us. And so you actually have to make Nginx use persistent connections. And you can tell it, how large should the pool be, how many requests per connection before you shut it down, how long before it idles before you shut it down, and so on and so forth. Because another fun fact, EPA doesn't do multi-threading. So you actually have to be careful to not open more connections than they have processors, because then, the parallelizing you're doing is actually doing more harm than good. So there's a lot of technical details. Anyhow, one more problem we have to look at when it comes to non-functional requirements is that we had to think about solving distributed transactions. So the problem here is the write operations. So when we do actually tell EPA to block certain seats, like make a reservation or free them up because we're canceling things. The scenario is this. Our user puts a certain ticket with his seat reservations into a shopping cart, and we want to guarantee that those seats are reserved for him for a while. And then what we do is we make the reservation in EPA, and so the seats are blocked. And now if this user decides to, I don't know, go for a shower, leave his laptop for a while, then after a while we need to free those up for other people to make the booking. And now obviously what can happen is that we make the cancellation request to EPA, and for some reason we don't get a response. This can happen in distributed systems for reasons, I don't know, there's plenty. Maybe they did respond, we just didn't get it. Maybe they didn't get the request. Maybe our timeout was a bit too short. I don't know. Plenty of reasons this can happen. And now the problem is, if we don't get a response for the cancellation request, we don't know what the actual state of the inventory is, right? We don't know if the seats were actually freed up or if they're still reserved. And if we don't solve this, like if you say, oh, let's just do, eventual consistency, the problem is we'll end up with trains whose seats are blocked by those reservations who have never been cancelled. And so it looks like the entire train is booked out, but if on the day off you went physically on the train, you would find that it's empty because it's all, cancellations from a distributed transaction that didn't actually get through. Now, this is not a new problem or anything in distributed systems. The way you would solve it today is, for example, you would use the Saga pattern. But then again, this one requires to have some sort of, middleware, for example, a messaging or event system. Obviously, EPA does not support them. Another one is you could do the traditional way. You can do an actual distributed transaction. There's, the two-phase commit protocol for that, XA transactions for the Java guys, for example. Of course, EPA does not support that either. And so what we had to do was to essentially build our own, transaction scavenger that keeps note of all the write operations on EPA and whether they failed or not. And then you have to keep doing compensation requests until you finally get a response that either says, what you're doing is stupid, I'm already done, and then it's fine, or it needs to keep retrying. And so we had to solve that as well. And I mean, anyone who has ever even considered doing his own transaction management knows how much of a pain that was, but still, it needs to be done. Right, and so the story so far is that originally what we started out with was we had, our sales platform and EPA, and we drew the line, and now all of a sudden we have this. But none of the things I've talked so far is, I didn't make any of this up, like, right? I mean, everything, I hope at least, makes sense. Like, it's just the consequence of distributed systems, I guess. And so the hard part, or the sad part, depending on how you want to see it, is we didn't even look at any of the functional requirements yet, have we? Yeah, and so at some point when you do reservations on trains, you need to actually take a look at, the physical inventory we have. Like, what do the trains actually look like? Because on our tickets, our customers, we print to them, you're sitting on coach, I don't know, 21, seat 11, by the window. Maybe you have a reservation, you need a reservation if you bring a bike, for example. Maybe you're seated in a family department, compartment or anything. And to solve this, there's something called the fatsoic lexicon. This is publicly available. It translates to, it's sort of an encyclopedia of all the trains in the inventory of Deutsche Bahn. And in the introduction, it says that it's essentially a concise summary of, all the trains, what do they look like, and you can find all kinds of interesting stuff. Like, I took a picture here. This is from one of the newest generation of trains, ICE4 we have. It has all kinds of information. For example, it says, top speed, how many coaches does it have? And then there's the entire layout. You have, for example, a restaurant on board, and then you have the different kinds of coaches, different kinds of compartments, which way are the seats oriented and stuff. This is unfortunately things you need to think about when you do the seat reservation stuff. And now, as always, unfortunately, details matter. And those of you who have a bit more experience probably noticed this. What I showed you was page 117 of 269. And that's just German trains. And you need to, like, if you want to do reservations on all trains that go day in, day out, you need to somehow support all of them. No way around it, unfortunately. And that's why, in the past, I guess, the attempts of, creating a new reservation system have been so hard. So the lesson learned here is that, details matter, and doing this broad strokes approach of doing, legacy replacement, legacy integration is slippery slope, to say the least. Now, I want to show at least one of the interfaces in EPA. And it's actually, so over the years, obviously, there have been new ones that came piling on. But since the core functionality is making seat reservations, it's one of the oldest ones. And it's the API or the interface to actually making a reservation on a train. And what it takes as arguments is roughly, you tell it what train. I chose the example of ICE 690. I think this one goes from Munich to Berlin. And then it asks you, okay, on what interval, on what segment do you want to make a reservation? I chose Frankfurt to Berlin. And it needs to know on what day and how many people. And a bunch of other stuff, but basically that's it. And the question to you is, what do you think this interface would look like in a system that's been 40 years old? And actually, I think I have time here. I made it a mission to give you a minute and actually see. I have so much space here for activities. Like it's really big, really. I'm sorry, Mr. Cameraman. I'm sure he hates me right now. I go back to the podium. Right, and the way let's break the suspension here. The way it looks is like this. Like this is how you make a reservation request to EPA, given the parameters. And it actually, you can't obviously see it from where you're sitting, but I actually looked in your faces, and reactions again have been quite similar to what we had. It's some people are like, okay, that's funny. Some are like, that's interesting, and some are a little shocked because realization is that we're going to have to build a mock for this. Yeah, obviously, isn't it? Like whenever you integrate a third-party system, you want to do testing, you gotta have a mock for this. So what are we looking at? It's a bunch of numbers. At least it looks like it, but it's actually hexadecimal numbers. And what you can do is you put this string into a converter that takes hexadecimal and converts to ASCII. And then that's not really what it is. So basically, it's encoded in a hexadecimal way, and parts of it are human readable if you do the conversion. Like I've tried to highlight the parts where you can see how it works. Like, does my clicker thingy work? Ah, there it is. Okay. So you have 4 people here, right? And then you have the train number 690, and then you have a date, July 14, the time 12:14. You're going from Frankfurt to Berlin. It's a booking in EPA, and the train is an ICE, right? So that's basically the way it works. And this brings me to the topic of doing testing. So we need a mock for doing this, and in the integration itself and in the mock both, what we're going to do is we're going to have to do a translation of the binary stuff into something human readable, and then do some logic on it, and then re-encode it to pass it to EPA or to make up a response. And the way we did that is we used wiremock for this, the standalone version that you can run as a Docker container, and there's actually a cool feature called custom transformers. And the way it works is you tell it to match a certain number. Again, I have to look here. You make it match to certain requests, and you tell it which request. So it's this URL path, and then if it's a post request, and if it contains a certain header, and in this case, we wanted to match all requests with the MIME type application octet stream. Did anyone know this MIME type? Oh, okay, great. The official documentation on the RFC says octet stream is for arbitrary binary data, and I think that's perfect. Like that couldn't sum it up any better. Okay, right now. Uh, I'm going to get to the end here slowly. So originally the question was, how do you how do you come up with future-proof software? And I use this obviously as an example, and there's still though a whole bunch of things I think we can learn from this. Like the first one, for example, like why is it so hard? Well, a famous quote comes to mind, which says prediction is very difficult, especially about the future. And that's true because you can't know what's going to happen. No matter how hard you try, there's always going to be things coming up that you didn't anticipate. And that's why this is obviously so hard. So the best you can do is to try and keep things, on the one hand, as not fancy as possible, right? That's one of the biggest learnings we had. Because whenever they decided to do things in a fancy way, either be it API design, be it, the documentation stuff they did, this always gave us a headache. So really, I mean, everyone knows about KISS principle, but this really, really shines through here. And if for some reason, like on occasions, there are good reasons for doing things that are fancy, then at the very least, you should make sure to document why you did it. For example, architecture decision records would be, in my opinion, a great idea for this. Because the way it is with what we had, there was no one around anymore to explain to us why it worked the way it did, right? And so if you do, in fact, decide to do something fancy, for example, good reasons might be, performance reasons, if it's really pretty critical. If there's, technological reasons, there are some, but then please make sure to, give people an idea of, what was your choice you made, what were the options that you weighed, and for what reasons did you decide to go the way you did. And closely related to that is we actually run into the trap of not managing knowledge in the organization itself. So the way it is with EPA, the few people who are still around and ran it, they treated it as sort of a black box, I guess, They couldn't really explain the way things worked, but they accepted that it did mostly do what it was supposed to do. And actually what happened was that, at some point we had to get down in the trenches and do the heavy lifting of translating all the binary stuff and so on. And that period went on for like, I don't know, maybe a year or so. And the people who were involved with doing the in-depth things of doing the translation, they moved on after a while. I mean, you've seen that we've been working on this for 5, maybe 6 years. And if the people who, did the difficult part of, thinking through it, to understanding the way this translation works, they move away. That's what happens, right? And if you don't make sure that the knowledge is spread in your team, then it's going to leave with your people. And then, we have our mock solution, and we have obviously our implementation of doing the translation and stuff. And then this becomes a black box in turn, because no one is around anymore to understand how does the translation work, because no one's around anymore to understand what's being translated. And so you need to be very careful to do an active, knowledge management in your teams and in your organization. And actually, it's the other way around as well. Once the implementation is in place, people leave, new people join your team, and they start working on new features. And every once in a while, it's going to be required that they take a look into the deep down stuff, and they're going to be like, "Ugh, that's very weird. I want to try and avoid that," right? And you need to do a lot of pair programming, and actually, guide them and introduce them to us, because then otherwise everyone's going to be, "Ugh, I'm going to try to avoid that," and then you're running into the same trap that they did in the past. Now, another thing is that, I guess it comes back to the question of like, is there such a thing as future-proof software that's going to run forever? And the answer is obvious, really. Like if your idea of future proof is that you build a system once and you do it really well, and then you just keep it to you just put it into a box and keep it running for 20 years and never touch it again. Obviously, there's no such thing, right? And then what it really takes is you need to be aware that it requires managing the life cycle of your software. I think there's two ways you can approach this. Either you accept that you need to constantly invest into it. You need to constantly solve all the technical and domain debt that will uh, inevitably pile up over time. You need to address it. Or you can go the other way and say, okay, I'm doing like planned obsolescence. I accept that this is going to be broken or unmaintainable in 5 years. And I have a plan that in 5 years I'm just going ahead and just replace it entirely. That's where you can go as well, I guess. In general, my advice would be to be very careful of doing, these broad strokes. I obviously like it was a bit tongue in cheek when I gave the enterprise architecture thing, but still, we have a tendency to oversimplify, and this is going to bite you in the long run. And yeah, third one. About the migration effort. Like I talked a lot about the integration when it comes to replacing legacy systems. Unfortunately, what I see very, very often is people look at, the legacy system they have, and they take inventory of all the stuff it does, like they make a map of all the features it has, and then what they do is they build a new one that replicates all the functions the old one had, and then pile on new stuff. And that's the worst thing you can do, right? What you really should be doing is you should be cutting off any of the old ties you had previously, because that's exactly what got you into the mess the last time. Why would you do the same thing over and over again and then end up with the same mess again? You need to learn from your mistakes, right? And so you have to be, and it's actually hard. It sounds very simple in principle, but when you talk to the people who used to work on the old system, every time you talk about new features, the first thing they're going to be saying is, the way we used to do this was this and this and this, and we had processes that looked like that. Instead, what you need to do is think of new processes, think of better ways of doing things. It sounds very simple, but I can tell you it's actually in practice quite hard because people are very averse to change. And now finally, actually, what I can say is that, every time I've been working with any legacy systems, because it sounds boring, and oftentimes people will say, oh, legacy, I don't care about it. Every time there's been so much I learned from this. Like in this example, starting with distributed transactions, we had the whole TLS handshake thing, the protocol, we had, timeout chains, circuit breakers, service mesh, caching. There's so much fine tuning we had to do, like with the load limitations. There's so many parameters you can play with who have, do small tunes and they have large impact. To me, it's always been, actually, I learned so much. So, yeah, I guess you should really see it more as an opportunity than a challenge, I guess. Right now, that's me with 2 minutes left, I think. Right, yeah. Then I'll just skip this one and get to the end. Thanks so much for sticking through. For those of you who are not, thirsting for the free beers that have been offered to us, I'd be happy to answer any questions, and maybe you have your own views or experiences to share. Thank you.
Yeah, thank you for the talk. Maybe I missed it in the first place, but why did you have to integrate the old system and couldn't simply write a completely new system with the new features and without the old ties?
I think I mentioned this. So the idea was that we wanted to go into production as quickly as possible with our sales platform. And so in order to sell tickets that are valid, like on the train, like, when they make checks and stuff, you need to also be able to sell reservations along, because we need to there are some connections where reservation is mandatory, and that's the reason. Yeah.
It's not really a question. First of all, thank you for the talk. I find my own experiences related. I also like to work on legacy systems. Just a quick story to share. You were actually lucky because you had somebody and you had some specification.
Yeah.
My favorite experience was when the customer said, we don't know what it does, but it has to be replicated exactly in the new system.
Wow. Okay.
And then you have to do comparison tests. Essentially, you had the old system running some input data, and the new system had to produce the same output, but you had no idea, actually, no specifications.
Crazy.
Consider yourself lucky.
Okay. Actually, if you stay around for a bit, maybe let's talk after. I'd be interested to hear about that.
Last question. Because then there is question somewhere.
Sorry, the beer is getting warm. Maybe the main challenge is to create the adapter in a way that is not a replica of the pure API of your legacy system.
Yeah, absolutely. Yeah,
and
for
how
sure.
did you tackle that?
We're doing consumer-driven contracts. So in a way, the domains that do the booking process, they dictate what our API should look like, and the adapter needs to handle translating that into binary stuff.
Okay, thank you.
Okay, I believe time is up. That's it. Again, thank you so much. And to those of you who are leaving by train, may your trains always be on time. Thank you.